This is section 5-8, and we'll be talking about cube root equations. So if we want to solve for a variable if we have a cube root. So we have the equation 3 open, 5n minus 1 closed, raised to the 1/3 power, minus 2 equals 0. We want to isolate that variable n, and so we need to start rearranging things to isolate that. So first we have this minus 2. Move that to the other side. So we get 3 open, 5n minus 1, all raised to the 1/3, equals 2. And then on the left we still have 3 times everything in this inside the parentheses. So we want to divide each side to get rid of that 3. So we're whittling down, getting to the point where we have just the variable. So we divide each side by 3 and we end up with, on the left, open parentheses, 5n minus 1, close parentheses, raised to the 1/3 equals 2/3 because we divided each side by 3. So now if we have something raised to the 1/3 power, as we do on the left side, that's the same thing as taking the cube root of it, because remember, if we raise something to a fraction, your exponent's a fraction, your numerator is the exponential value of your base, and your denominator is the index number for your radical. So what we need to do to get rid of this radical is, if we have raised to the 1/3 power, we need to multiply each side by the 3rd power, because we want our exponent on our left side to be a 1. So 1/3 times 3 gives us 1. So what does that look like? Okay, so we have open bracket, open parentheses, 5n minus 1 close, raised to the 1/3, close bracket, to the 3rd power equals the fraction 2/3 raised to the 3rd power. And the reason I use brackets is so that we can see we're raising that whole entire expression to the 3rd power. So when you're raising a power to a power, you multiply them. So 1/3 times 3 is 1. So on the left you have 5n minus 1 equals 2/3 raised to the 3rd power. So we raise our numerator and our denominator. 2 raised to the 3rd power is 8, so our new numerator is 8. 3 raised to the 3rd power is 27. So now we have 5n minus 1 equals 8/27. Okay, so now let's start whittling away again. We have 5n minus 1, so let's add that 1 to the other side. 5n equals 8/27 plus 27/27. I just turned that 1 into a fraction, which equals 5n equals 35/27. So 5n equals 35/27. So then we need to divide each side by this 5. And when we are dividing fractions, because the right side is a fraction, we flip it over and multiply. So we get n equals 35/27 times 1/5. And we can simplify, cross cancel 35 and the 5. So on the new numerator on our left fraction, 5 goes into 35 7 times. And then that 5 and the second denominator becomes a 1. So we end up with n equals 7/27, and that's our answer. So that is example 3 on page 264. Okay, now we're looking at page 270. This is section 5-9, complex numbers, or our imaginary numbers. So example 1, it's asking us to simplify the square root of -18. So we need to simplify this, pull out everything that's a perfect square, and we have to pull out this negative. And if you remember, I is our variable that we use to indicate an imaginary number. So I equals the square root of -1. Therefore, I squared equals negative 1. Because if we have the square root of negative 1 times the square root of negative 1, which is, we would have just negative 1. So that's why I squared equals negative 1. So if we have negative 18, let's break this apart. So we can say that the square root of negative 18 is the same thing as square root of 9 times the square root of 2 times the square root of negative 1. That accounts for all the pieces of negative 18, all the factors. So now we can look at this and what can we pull out from underneath the radical? Square root of 9, so that's 3, because 3 times 3 is 9. And square root of negative 1, well, that's I, so we have 3I. And square root of 2 we can't do anything with, so that's just left as square root of 2. So now we have 3I square root of 2. Okay, so what if we have a variable under there? Something like square root. Okay, we have square root of negative 125 x to the 5th. Again, we just need to break this down into the factors. So what does this look like? This looks like square root of negative 1 times the square root of 25 times the square root of x squared times the square root of x squared times the square root of x. And I broke it down like that because if it's a squared, then we can pull it out because we're doing square roots. So then let's simplify this. So square root of negative 1, what does that equal? That equals I. Okay, so we know that square root of negative 1 is I. So all of this equals, and then we have square root of 25. So we know that's 5. So now we have 5I, put the integer first, and times the square root of x squared, which just leaves us with a times an x. And we have square root of x squared times x. And the last one is we have square root of just x. So that cannot be pulled out of the radical sign. So we have square root of x. And then the last piece is times square root of 5, because 25 times 5 is 125. So what I have now is 5I times x times square root of x times square root of 5. And when we simplify this, we end up with 5I x squared times the square root of 5x. So that 5x we can't pull out from underneath the radical sign. And so that's as far as we can simplify this down. Okay, now let's talk about multiplying pure imaginary numbers. If we have something like negative 2I times 7I, it's like multiplying constants and variables. You multiply your numbers. So we have negative 2 times negative 7 is negative 14 times I squared. So now we have negative 14 I squared, but we can't leave it like that because we know I squared is negative 1. So we have negative 14, open parentheses, minus 1, negative 1, close parentheses. So now we have negative 14 times negative 1, which gives us a positive 14. So we can say negative 2I times 7I equals 14. So what happens if we have negative numbers under the radical that we are multiplying? For example, square root of negative 10 times the square root of negative 15. Let's pull out everything we can from underneath the radical. So square root of negative 10, the only thing we can pull out of that is a negative 1, which becomes an I. So then we have I square root of 10 times, and again we have a negative 15 under the radical, so we have I square root 15. And when we're multiplying radicals, we multiply what's outside of the radical first, I times I, so that's I squared. And then underneath the radical, we have 10 and 15. So we have I squared times the square root of 150. But we can pull things out of that 150 that are perfect squares to simplify this down. So 150, looking at it in terms of factors, is we have I squared square root of 25 times 6. And we can pull out that 25 because it's a perfect square, so that comes out as a 5. So we have 5I squared times the square root of 6. Now that I squared also is we can rewrite as negative 1 because I squared equals negative 1. So we have 5 times negative 1, 5 open negative 1 close, times the square root of 6. And that equals, so 5 times negative 1 is 5. So we have negative 5 square root of 6. And that is your answer. Okay, moving along, we have simplifying a power of I. So what does that mean? So if we have something like I to the 45th power, we want to break this down into groups of squares. We want to turn it into I squared raised to some power. And we know the property of multiplying a base raised to a power, you add your exponents. So let's break down this 45. So we can say I, open parentheses, I squared, because we want them to be squared. And looking at 45, 2 times 22 gives us 44, which is 1 away from 45. So if we have open I squared closed raised to the 22nd power, that's the same as I raised to the 44th. But we need to get it to 45, the exponent to be 45. So you have I squared raised to the 22nd power times I, which is the same thing as I to the first. You end up with 44 times I to the first, or I to the 45th. So it's basically just like rewriting it. But now, let's look at this. So I squared to the 22nd power. I squared is also negative 1. So open negative 1 raised to the 22nd power. I'm just writing it in terms of that negative 1 instead of as an imaginary number. So we have negative 1 raised to the 22nd power times I, because we want it to be up to that 45th, so we can't forget that second I. And negative 1 raised to the 22nd power is a positive 1. So we have 1 times I, so our answer is just I. So I to the 45th power is the same as I. Okay, now what if we have something along the lines of I to the 32nd power? What does that look like? So we want to see what happens if we have I to the 32nd power. So again, looking at it in terms of I squared. So we have open parentheses. I squared raised to the 32 divided by 2 is 16. So I squared raised to the 16th power is the same thing as open negative 1 close raised to the 16th power, which gives us a positive 1. Because negative 1 multiplied together 16 times would give us a positive 1. So I raised to the 32nd power is a positive 1. Okay, and the last example is example 4, page 271. Now we need to solve. So if we have a problem like 3x squared plus 48 equals 0. So we need to solve again for that x. So we have to start simplifying this and isolate our x. So we have this plus 48. So we have 3x squared equals negative 48. Moved it to the right. 3x squared equals negative 48. Divide each side by 3. On the left we have x squared equals negative 16. Okay, and to get that x by itself, we have to do the square root of each side, because right now it stands as x squared. Square root of x squared is x equals square root of negative 16. Okay, we know it's a plus or minus. We're talking principal root here. So looking at this, we have this negative 16, so we need to break this out again. So you have to take out that negative 1. So we have plus or minus the square root of negative 1 times the square root of 16. Square root of negative 1, x equals plus or minus I, because that's that square root of negative 1, times the square root of 16, which is 4. So our answer is x equals plus or minus 4i. And that would be our answer. The key here is to make sure you pull out that negative 1. So you make sure you incorporate your negative or your imaginary numbers into that.